Okay, our goal with those is to get them done within like the first 3 to 5 minutes of class. We're still spending like 10 minutes of class doing that. So let's just make sure when we come in immediately, go to the textbook check, get it done so we can begin. Okay, this section covers a few different objectives. The first thing is we talked about congruence last week, but it was just by happenstance. It wasn't part of the lesson. Today is where you actually learn what congruence is. Okay, and so congruence means exactly the same shape, exactly the same size. Okay, so if two angles are congruent, it means they have the same measure. If two segments are congruent, it means they have the same length. Okay, and we identify congruence, like if I wanted to show that these two segments had the same length from here to here, there's two, I would just draw a mark through it, and that mark indicates those two segments have the same length. Okay, we talked about angles, and congruent angles, like here, if these two are congruent, they're going to have that mark. It shows they have the same measure. Okay, we write congruence with an equal sign and then just a little squiggly above it. When you see that, you know that the two things on either side of that symbol are exactly the same length or shape and measure. Okay, so if I wanted to say these two segments were the same length, that's how I would write it. Okay, the measure of AB equals the measure of CD in this case, but if I wanted to write it as a segment to show that the segments have the exact same shape and size, I use the congruent symbol and put it between them. So it looks like the equal sign, but it's got a little squiggly line on top. That's the congruent symbol. Questions on that? Okay, another concept in this section was midpoint and learning the midpoint formula, which again is something you should have learned early, but sometimes you make it this far and haven't. So if I want to find the midpoint, between these 2 points, okay, first I'm going to identify what the 2 points are, what their coordinates are. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And then this is -3, 1. Okay, so if I know the coordinates, the midpoint formula says I take the two x coordinates, so in this case -3 plus 4, I add them together, I divide by 2. It's the average of 2 points, really. And to do the y coordinates then, I take the two y coordinates, add them together, divide by 2. Okay, so this ends up being 1/2 and 7/2. So if I go over 1/2 and up, that's not right, 3, yeah, that's 3.5. Over half, up 1, 2, 3.5, and then connect these two, that point is the midpoint, which means it splits this segment into two congruent parts. Follow, Isaac?
Yeah.
Okay. All right, so the formal way of writing that is we take the first x coordinate, we add the second x coordinate, and we divide that by 2. We take the first y coordinate, add the second y coordinate, and divide it by 2. And this is the coordinate for your midpoint. So sometimes you might be given 2 points, -2, 4. Actually, let's make this one a little closer. And 2, 3. And you're told that this point is the midpoint of some segment. That this is the end point, this is the midpoint, and you want to find out where that end point is. You're given one end point and a midpoint. Understand the question? Okay, so to do this, what you're going to do is you're going to use this formula. You know that this represents the coordinate of the midpoint, the x coordinate of the midpoint. This is the y coordinate, right? And I know the midpoint. And I know x1 and I know y1. So I'm just going to fill this in and say negative 2 plus x2 over 2 equals 2. Make sure everybody follows that, because you may have a problem like this on big ideas, I can't remember, or CK12, where you're trying to solve for the endpoint. So I'm going to use the fact that the midpoint formula says I add the two x's on the ends, and I divide it by 2, and that gives me the x-coordinate of the midpoint. So I know the x-coordinate of the midpoint here is 2, and I know that one endpoint is negative 2. I'm looking for the other endpoint, the x-coordinate. So I'm just plugging it in here, and I'm leaving the variable as the unknown, what I'm looking for, the x-coordinate of the other endpoint. With me so far? Okay, so once I have this equation, how do I solve it? What's the first step?
Multiply by 2.
Good. And then?
And then add.
Okay, so the x-coordinate of the second endpoint is 6. Now I have to do the same thing and find the y-coordinate. Okay, so I'm going to use this equation. y1 is 4. I don't know the other endpoint, so I'm going to leave that. Divide it by 2 and set it equal to the y-coordinate of the midpoint, because that's what this formula tells me, what the y-coordinate of the midpoint is. And I'm given that. Everybody understand how I'm setting this up? Okay, now I'm going to solve again. So 4 plus y2 equals 6. I'm going to subtract 4. y2 equals 2. So the coordinate of the endpoint is 6, 2. I always like to just plot that and make sure it makes sense, because sometimes my math's wrong and I could get 8, negative 10, and it's like, there's no way that's right. Okay, so I always like to just ask, I call it the straight face test. Does it pass the straight face test? If I plot this, 1, 2, 3, 4, 5, 6, up 2. My guess was a little off, but that's all right. Okay, do these two segments look equal? Yeah. So I feel pretty good about the math. Okay, so we can use the midpoint formula to find the midpoint, but we can also use it to find endpoints if we're given the midpoint. So it'll help you in both ways. With me there? Okay, so if I'm given, I think I wrote a couple problems from the book just to illustrate complexity sometimes of what these figures look like. And let's go through here. 90. And here. And I'm told that this is true. Okay, so one thing we haven't talked about yet is something called a bisector. A segment bisector is a line or a segment that bisects another segment, creating two equal parts. Okay, so a segment bisector, if I've got this segment, to bisect it, I've got to go through the midpoint with a line or a segment to create two equal parts of that segment. This is called the segment bisector because it bisects the segment into two equal parts. Okay? If this segment bisector, this line, happens to do that at a 90-degree angle, it's called a perpendicular bisector, which just means it comes down to that segment, it splits it in half, but at a 90-degree angle. Okay, so we have segment bisectors, we have perpendicular bisectors. Not all segment bisectors are perpendicular, but all perpendicular bisectors are segment bisectors, if that makes sense. Okay, so here's an illustration of a line that's MN. I have the segment MN, just that distance from M to N. I've got it split by two different bisectors. OQ is a perpendicular bisector because it comes in at a 90. ST is just a segment bisector. It doesn't come in at a 90-degree angle, but it still splits that segment into two parts. Okay, so you need to understand the difference. If you're told it's a perpendicular bisector, you're given a lot of information. You're given the fact that it splits, so you know those two segments are equal, and you also know it comes in at a 90-degree angle. This is how understanding that nomenclature might help you in solving a problem. So here's an example. I have this segment, and it's split, and I'm given this. Okay, I'm given this information. This is just a point. So if I were to say out loud what has been given to me, I could say, let's call this ST and MN. I could say segment MN is bisected by segment ST at a 90-degree angle. So a segment ST is a perpendicular bisector. Okay. Now, if I'm asked to solve for x, what information can I use to do that? How can I set an equation up? Yeah, set those two pieces of the segment equal to each other, because I'm told here they are in fact equal. So I'm just going to set up an equation like so. Okay. Add 6. Solve for x. If I was asked to find the length of the segment, well, I know it's 21. Because this segment is, that segment has to be. The length of this segment is 21. The whole length then would be 42. But now I've solved for x. X is 9. Okay? Now, this question, to find y, do you see the degree symbol right there? Okay, that's telling me that 4y minus 2 is representing this degree, this angle right there. Well, what is that angle? Say it, Isaac. 90 degrees. If this is 90 and this is a straight line, that has to be 90 because together they have to make 180. Right? So just because it's not marked on every corner, as long as it's marked on one, I know all 4 of them are 90 degrees. Does that make sense to everybody? So now I'm going to use that information and say 4y minus 2 has to equal 90. That's how I'm going to solve for y, because this expression represents the angle right there in the corner. Okay, and now to solve, 4y equals 92. Y equals what? 23. And now I've solved for y. Okay, so this is how we're going to be able to use information you're given, like angle bisector, or segment bisectors, perpendicular bisectors, to actually solve equations. The last piece of this section is very similar, except we're dealing with angles. You're going to find angle bisectors, which are lines or rays sometimes that will split an angle in half. Okay? So if I'm given this, what could I set up to solve that? 3x minus 7 equals 2x plus 3, because those are equal. And then just solve. Okay, questions on anything in this section? Okay, go ahead and start on CK12. I'll get big ideas open right now. Yes.